Should be a quick one. We have seen a bunch like this before, differential equation problems. So for part A, it helps me to write those few points down. So I jotted down the dots and I simply took the x's and y's, plugged them into that derivative equation, got my slopes, and I did that. I made my little hash marks there. So slope of 0 is horizontal. And if I had a slope of 1, I kind of made that somewhat steep. And a slope of 4, you had to make that steeper than the slope of 1. So it's all relative that you got to be able to tell just by looking at which is the steeper one, which is the less steep in the horizontal stuff right there. Now letter B, notice again, it doesn't say find the particular solution yet. That's what letter C is talking about there. So you don't want to do that stuff too soon. But on letter B, it says write the equation of the line tangent to the graph. So that's writing the equation of the tangent line right there. So that gives us a point, 2, 3, the initial condition, and then it gives us got the point, and then we need to find the slope using the derivative. So since I have the point, I'm going to take the x is 2 and y is 3, plug that into the first derivative right there, and that's how I'm going to get 9 for the slope. And then that's the slope of the curve, the slope of the tangent line. Do your point slope form, boom, there's the equation of the tangent line. And then it says use that equation to approximate f of 2.1, which means you're going to take the 2.1, plug it in place for x. Now you could plug the 2.1 in place for x right there. I got 0.9. If you have trouble with the decimals, switch to a fraction, right? So that's 9/10. And then if you add 3 to both sides, that's 9 over 10 plus a 30 over 10. And you can leave that as 39 over 10. You're allowed to leave it like that. If you want to make it 3.9, you can. Also, a lot of times if I have to use it for something, sometimes what I'll do is that's when I'll get the y by itself. So I'll distribute the 9 with the 3 over, get this equation of my tangent line, and then you can plug in the 2.1. Either way, you're going to get the 3.9 answer right there. So find the tangent line, point slope form, plug in the number, get that approximated value. And then letter C is what we've seen a bunch of. It says find the particular solution to the differential equation, gives us the initial condition. So these are the ones where you're going to separate your variables, get the y's with the dy, x's with the dx, integrate both sides, and then use that point that they give us, the initial condition, to plug it in to figure out what that c value is, and then we could solve it the rest of the way for the y. So first thing I'm gonna do, I'm gonna start with my dy dx, multiply both sides by the dx, and then that y, I have to do legal algebra, so I'm gonna divide both sides by the y squared, got the y's with the dy, x's with the dx, now I'm gonna do an integral. So this side is gonna be the ln of x minus 1, but this side here, this is not 1 over a single letter, so that's y to the -2. That's your normal power rule. But y to the -1 over -1, that becomes -1 over y equals that. And then I'm going to stop right there, take my numbers, plug the 3 in for the y, plug the 2 in for the x. Ln of 1 is 0. I get my c is -1/3. And then you're going to plug that in right there. And then I came over here, and now we're supposed to solve this for y the rest of the way. So what I was trying to do, I got 2 ways that we could solve this here. When I was trying to solve for the y, I needed to get it out of the denominator. So I multiplied both sides by the y. Then I divided both sides by the other stuff. And then I had a complex fraction, so I just multiplied the top and the bottom by the same thing to get rid of my complex fraction right there. So there's one way you could do that. Another way you could do that, right here, when I plugged in the -1/3, you can move the -1/3 to the one side. And then go ahead, you could get yourself like a common denominator right here, because you're trying to create where you have like a fraction equals a fraction. Then you could either multiply or cross multiply, whatever you got to do there. But then I just multiplied both sides by the 3y, and then what did I do? I moved all my y's to the same side, and then I factored out, and then I divided, and then I had that answer right there. So I like that first way better, but there's more than one way you could solve these things. Sometimes just get that y by itself, and then everybody's happy there. Squirrel.